Oh my goodness, guys and gals, it is me, Coach Goo, and we are here with an Algebra 2 non-flipped classroom video. That's a little weird to not say geometry, flip classroom video, but we're doing Algebra 2 now. This is the very first day. So let's warm up with some not too taxing on the mind here. So we're starting off Unit 1, Section 1. It's all about relations and functions. Relations and functions. So the Unit 1, Day 1 objective. We're going to be able to graph relations and identify functions. All right. So let's just take a look at this right here. Check out this example. Skydiving. When skydivers jump out of an airplane, all right, they experience free fall. They're just falling freely. The photos show various heights of a skydiver at different times during free fall, ignoring air resistance. How can you represent this relation in 4 different ways? Check this out. At 0 seconds, he's still in the airplane. He's 10,000 feet high in the air. At 4 seconds, he's 9,744 feet high in the air because he's falling down a little bit. 8 seconds, he's dropped more. 12 seconds, he's dropped even more. 16 seconds, he's dead. No, just kidding. He's dropped even more. So let's look. There's 4 different ways we can represent this function. Now check this out. What is a relation? Remember, this is all about relations and functions. So first, let's define this relation, all right? A relation is, oh, whoa, what the? A relation associates the elements of one set, which is the inputs, with the elements of a second set, which are going to be the outputs. And the relations, as we said, can be represented in 4 ways, all right? Way number 1, we got mapping a diagram. You got one side on the left side, one side on the right side, and then you draw these arrows connecting your inputs and outputs. Way number 2, we got ordered pairs. This is the classic. You guys should know this one. Ordered pairs, you know, you're just gonna put the parentheses in the pair, like this. All right, but we've got it inside a set this time because we've got many ordered pairs. Oh, look at this thing. Think, what is the input? What is the output? The input is the time, and the output is how high he is above the ground, because based on the time, the height changes. All right, number 3, we got a table of values. That's just a classic table. And then number 4, we've got the graph. So make sure you remember these 4 different ways and what they're called. Mapping diagrams, that's probably maybe the newest one with the input section, the output section, and then the arrows. We got the ordered pairs, we got the table of values, and the graph. All right, moving on. Problem 1, got it? Represent this data using a mapping diagram, ordered pairs, table of values, and then finally graphing. So guys, I want you to take some time and attempt these 4 different ways of representing this function, the average temperature in Houston. All right, so let's take a look at 2 different types of functions now, okay? And we've talked about the relations. Let's go to the functions. All right, there's 2 types of functions here. There are discrete functions, and there are continuous functions, all right? So check out this discrete function on the left side right here. You can see we've got a set. The set is, you can see the set because we've got these brackets of ordered pairs. A discrete function is a function that only exists for the given values of its domain. All right. In other words, it's disconnected. It's got distinct values. You see, our points are -2, 2, 2, 5, 4, 5, 8, -3, and 10, 8. All these other points, there's nothing there. Look, when I see x is 0, is there even a y somewhere there? No, there's nothing there. There's no function there. This function only exists on the points -2, 2, 4, 8, and 10. You can see that some values in between are impossible because like there's just nothing there. There's just nothing there. And these are countable. All right. I can count straight up 1, 2, 3, 4, 5 spots there. All right, next, let's take a look at the continuous function. What do you think a continuous function is? It's a function that works for any real values in the domain. All right, and some ways you can tell that it's a continuous function is if it's connected. You can always get between any two values. Look, if I pick any two values, like let's pick like -2 and 4 over here, anywhere in between there is a value for the y. And you can measure this. These are usually measurable things, all right? So let's move on. All right, next up we've got domain and range. This domain is the set of all inputs, independent values, or x values. These are 3 different ways you can identify the domain. Inputs, independent values, or x values, okay? And then the range is going to be the set of all outputs, dependent values, or y values. So if we look at the relation that we had, 0, 10,000, 4, 9,744, 8, 8,976, 12, 7,696, and 16, 5,904. What are the domain and range of the relation? And remember, we're going to write, remember, it's a set. It's a set. What do we use to notate the set? We put our brackets around our possible values. Identifying, let me scroll down here. Next up, identifying functions. A function is a relation in which each element of the domain is paired with exactly one element of the range. Let's go ahead and just look through these 3 examples, A, B, and C, and tell which one's a function and which ones aren't. And guys, at the end of these notes, we've got this new addition right here. What did we learn today? It's good to let yourself know and recap what you actually learned today. What do you feel good about from today? Do you actually understand all the material? What do you kind of struggle a little bit with? Maybe you can ask questions a little later. What do you still have questions on? I mean, I guess, yeah, you know, those are kind of like hand in hand. What are you good at? What do you not feel so good at? But that's going to end our very first section of Algebra 2 Notes, non-flipped classroom with Coach Gu. See you in the next one. Peace.